Hello, you absolute legends. My name is Don Cavanaugh, and let's talk a little bit about buffers. We have a buffer solution. We have an acid solution that we want to make into a buffer. So we are going to add an ionic compound to that solution. This is meant to be the acid solution. In this case, acetic acid has a 0.5 molarity. We have 300 milliliters of it, and we want to make a buffer solution with a pH of 5. You guessed it, we're going to do a rice table. We have a capital K value. We need an equilibrium concentration. So we're going to need a rice table. This is our balanced chemical reaction. And what we have here for our rice table, RICE. We know the initial molarity, 0.5 moles per liter. Because the capital K doesn't include liquid water, I'm just going to put an X through that there. This right here starts at 0, and this right here starts at X. We want to know eventually how many grams of this needs to be added right here. If you recall, the unit right here that this is in is not in grams. And I'll write the units out specifically just to be clear about that, okay? This is going to go down in our change line. This is going to go down some amount. This is going to go up some amount, and this is also going to go up some amount right here. And in our equilibrium line, this is going to be 0.5 molarity minus X. Okay. This equilibrium concentration of the hydronium ion, we have a target for pH 5. When you do the inverse of the negative log value, we want this molarity to be 10 to the negative 5th. Let me write that out in standard notation. Like that is the molarity we're shooting for here. And this is X plus X. Okay. When solving for our capital K expression, we often drop these terms for X because they are so small. Makes the math much easier down there. Our capital K value is up here, 1.8 times 10 to the negative 5th. Putting in our equilibrium concentrations, X times this number, divided by 0.5. This can be done with arithmetic and solved for X. Recall that X is the moles per liters that you want of your added ionic compound, the conjugate base of our acid here. So once you solve for X in moles per liter, you want this answer in grams. So you need to get rid of the liters, since we know we're given the volume, so we're going to use it. Since we know the volume, this would give us how many moles of X needs to be present. And the ionic compound added, sodium acetate, that's trihydrated. You would add all that up to get the molecular weight, grams over moles, and plug that molecular weight in here. Like whatever that is off the periodic table, moles cancel, and that would solve for the grams of hydrated sodium acetate that would be added to a 0.3 liter solution to get a pH of 5. I hope this helps. Thank you.